So thank you very much for coming to this session. I asked Sue, can I please prepare a presentation, a set of panel talks? And I didn't know what Cassie was going to talk about, even though I was just on the mine site with her. I forgot totally to ask what she was going to talk about. But what she talked about, for those of you who hit the keynote speaker, is rebanding this industry and how are we going to get young people into this industry. And really, when I set up this panel, I set it up to talk about innovation and technology because I think it's the one area of our industry that is super exciting that we never talk about. And that's how we're going to get young people engaged in our sector, is talking about all the different areas that they can work in. If you went to university in STEM, you can work in mining. There is a job for you somewhere. And what we want to do is empower everybody in this room, in this conference, to be champions of the industry and be interested in talking about what is the future of the industry. And the way that we can do that is talk about all the different aspects of our industry, the good, the bad, all of it, and have those hard conversations so that we are the champions. I'll give you an example that's near and dear to my heart, is that I play hockey. I came up here. I didn't know anybody when I joined the hockey league. Was on a hockey team with a young student at that time who was working for Icy Waters as a fish tech and had just started in university, was not really sure what she was going to do, wasn't even really sure what area of science she was interested in. But we talked the whole hockey season about what I was interested in, what my experiences are in working in industry. Fast forward 2 years later, she was looking for a summer job. And in our room, in our hockey room, we had people who worked for Yukon government, people who worked for the feds, people who worked for the city. Everybody was hiring for summer students and vying for them. And I spent a whole hockey season talking to Rihanna about, come into the sector, come work for me, come learn what the potential is. And it took the whole season, but I won her over. And now we have somebody who's doing their master's on mine remediation and going to be coming back up and being a leader in this area. But how we got her into the sector was being champions ourselves and being willing to talk about all the areas of mining. If you have a question, come and talk to me. I'll talk to you about anything. And that's how we're going to get people interested in mining. And then the other side is showing the future. And that's what I asked Sue to talk about, is not far off research, but what is the sector today and in the short term going to be? And that means our people who work directly for the mining companies, but also all of our service companies are innovating to match what mining needs. And that's a key aspect of mining too. So with no further ado, we're going to start with Tammy is going to be from Northwest Hell and talking about infrastructure. As all of you know, infrastructure is central. I mean, we've heard it over and over again at this conference, that if we're going to succeed in mining, we need the infrastructure on all different levels. Tim is from Ausenco. He's going to talk about geomatics and that side of our industry that really has fast-forwarded amazing. You know, I play video games myself. I used to think that people who were in IT were a certain type, but now it's everybody can do these things and become champions. We had a student who I hired did apps for us to digitize field work and to digitize our inventory. Like, everybody can build apps now. Then we have Rachel, who's from BQE. Originally, Hecla was going to talk on water management on their site, but they've graciously, when we discussed that really I wanted to talk about technology, that BQE was really who should be talking about water management. They obviously are on a number of sites in the Yukon, so they're the experts, and that's what we want to hear about. And then We've already heard many times about Nuance at this conference, but this is your chance to ask Jack all about it and hear about this exciting technology that really shows where the future of our industry is. So, Tammy?
Thank you so much, and thank you for having me on the panel. It's always a pleasure to participate in the Geosciences Conference, and it's great to be here at the Kwanlin Dun Cultural Center on the traditional territories of the Kwanlin Dun First Nation and Tahnquitchon Council. I'm glad to see such a focus on the environment this year. The climate changes that we're witnessing in the Yukon and the significant heap leach failure we experienced in the Yukon make it clear that we need to have this kind of conversation more often. For those of you who may be new to the North or just visiting, let me briefly introduce Northwest Hell. And for those who have been around for a while, I wouldn't mind reintroducing ourselves. There's been a lot of change lately. We're a tech company with just over 500 Northern employees, serving a uniquely wonderful and challenging region. You may have already heard, but earlier this year, 60 North Unity, an organization representing Indigenous groups across the North, announced its intention to purchase Northwest Hell for $1 billion. Although we're still awaiting the transaction to finalize, when completed, Northwest Hell will become the largest Indigenous-owned telco in the world. This ownership model will ensure that Northwest Hell's profits and decision-making stay in the North, benefiting Northern communities directly. We are North America's largest incumbent telco by geography. Our operating area stretches from coast to coast to coast, 3,500 kilometers from east to west, covering nearly 40% of Canada's landmass, with less than 1% of Canada's population. The landscape poses challenges for us for infrastructure development, but we don't let it stop us. To date, we've delivered fast, unlimited fiber-powered internet to 45 Northern communities, with many more to come. We've invested over $500 million in infrastructure here in Northern Canada over the last 10 years. This has resulted in city centers like Whitehorse getting 700 meg speeds with unlimited monthly data, but also small communities like Burwash Landing having access to those same speeds and prices as our northern city centers. Our goal is to bring high-speed unlimited to every community in Northern Canada. In the Yukon, we've reached over 95% of homes, and we're working hard to close the remaining gap. Like all of you, we operate on traditional Indigenous lands. With that privilege, I'm getting behind on my slides. There's our map, big territory. Like many of you, we operate on traditional lands, and with that privilege comes a responsibility to actively pursue opportunities that bring shared participation and economic benefits to those lands, to the stewards of those lands. I'd like to share one story with you about a way that we've successfully deployed a mutually beneficial model of infrastructure ownership in the Yukon. So let me introduce you to our shared pathways. Let me hope I get, okay.
From Northwest Hell's perspective, we believe that stronger connections create stronger communities. Through community consultations and talking to many of our communities, they're asking for faster internet. They're wanting more affordable internet. So this project enables faster internet, more affordable internet for our communities. But in addition, it provides direct economic benefits because we are leasing the network back from First Nation Development Corps, and they see some economic benefit for this for the next 20 years.
Shared Pathways Partnership is a major development, and that we're now First Nations own part of the telecommunications network in the Yukon territories. And now we're combining and finally accepting what has happened in the past, and we're trying to make those changes to integrate the Southern culture into the Northern culture. And communications obviously is a big part of this. And to me, that's a big step forward.
We live in a time of self-government and land claims, and these kinds of opportunities push the narrative forward in terms of reconciliation between corporate Canada and the First Peoples of this country.
Shared Pathways is an opportunity for our First Nations to get involved in telecommunications like I did, and I'm excited about it, and I'm excited to see what opportunities it brings for other young people in the North that want to stay here and work, and hopefully it'll provide them with those opportunities to stay here.
Most projects continue to fail when First Nations and Indigenous people are not a part of the decision-making. And as we continue to be a part of the decision-making, I think that we continue to educate each other, and true reconciliation, in my view, is a two-way street. This project reflects reconciliation through true partnership.
We don't want to stop here. We believe a partnership model like this can be expanded to other locations in the North.
Well, it's a move to involve the First Nations with a corporation like Northwestel. So it's huge, it's a start, and we look forward to much more in the future.
Something I believe the telecommunications industry has in common with the geoscience industry is how important local workforces are. We've heard about how hard it can be to bring technologically savvy folks into the North and into our industries. We're not talking just about Whitehorse, but also more remote communities that are important parts of all of our operations. There are obvious benefits of to be smarter with our expenses, and that's what having a local workforce helps us to do. We've seen a lot of northern operating organizations flying people up from southern Canada to remote sites to perform things like remote maintenance or basic troubleshooting. And this is an area where we found we can be really helpful. We have strong rural workforces who have smart and technical hands and feet, ready and able to support your industry in more ways than just connectivity. So I encourage you, the next time that you're thinking you need to book a crew from southern Canada to head north, give your Northwestel account manager a call. We may be able to help you fix or resolve your problem faster and more efficiently and more affordably. We're investing in our local workforce, and that we want to make sure that it remains Indigenous representation in our workforce, up from about 10% now. Over the past few years, we've been working with local education experts like Yukon University, the Yukon First Nations Education Directorate, the Yukon Government Department of Education to find creative ways to get more technical education into schools and help Northerners grow the skills they need to have a career in technology right in their backyards and see the opportunities that that technical education can provide for them. This ominous picture shows some of the devastation that wildfire has brought to northern Canada. Climate change has its fingerprints on all of us. We're no exception. The only silver lining is that it has driven us to innovate. We've learned a lot from the past few challenging seasons of fires and floods in the north and have made some significant advancements that I'd like to share. We've introduced OneWeb's low Earth orbit satellite solutions into our toolkit, and that also enables us to deploy connectivity rapidly in areas facing service disruptions, leverage ultra-remote parts of the North for mines, and some of our customers use it as backup or to serve as temporary purposes. The use cases for low Earth orbit are endless. One thing that we've done, I will be showing a video shortly that we actually debuted last year, so some of you may have seen it, but since that time, we've developed the ability to put the low Earth orbit satellites in our central offices, so that if low Earth orbit technology is something that you need for your mine and you're in our operating area, we're able to manage that technology for you, whether it's for redundancy or if it's a primary capability for you.
The Klondike Road Relay. It runs along one of the world's most iconic, scenic, and remote highways, crossing places cell service and internet don't reach. As runners prepare to brave the cold northern night, Northwestel is also reaching for the stars. For the first time, we're connecting this race from space. Using OneWeb low Earth orbit satellite technology, Northwestel technicians are keeping these off-grid racers connected to fast, reliable internet. It's the same technology we use to power mines, camps, and businesses across the north. If we can do it here, imagine what we can do for you. Northwestel and OneWeb. Fast connections anywhere.
As we grow these technologies used in the North, and as industries like yours adopt a variety of solutions, one thing to remember is the importance of bringing them together. You can have a fiber connection to power your main office in Whitehorse and downtown Calgary and a low Earth orbit solution in the field, but seamlessly connecting those sites together really benefits from the help of a tech professional. Even more so if there are multiple service providers in the mix. It can get tricky. The technology we use to integrate the connections can provide enhanced network diagnostic and monitoring, as well as security, which is so critical in today's environment. We're all at risk of cybersecurity attacks, so it's important for us all to do what we can to protect our networks. This type of stuff is our bread and butter. We're well versed in combining different technology types over our network and delivering one seamless, secure customer experience, and we can support you to do the same in your own network. My colleague Mill has put some handouts around that speak to some of the services I've talked about today and how to get in touch with us if you want to learn more. I've also got some colleagues from sales distributed across the room if you'd like to reach out to them and learn more. In the end, I'd like to end on a note about reliability, because all this tech is great, but at the end of the day, it's got to work. So I'll let you in on a secret. The Canadian North Fiber Loop is days away from completion. We'll soon be celebrating this news with the North, and I hope that you'll join us. The loop marks a new era of reliability for Northern telecommunications. If there's a fiber cut anywhere along this loop, whether from fire, a road washout, or a rogue backhoe, internet and cellular traffic can flow in the opposite direction, keeping the network live. Completing the Canada North Fiber Loop is the culmination of a decade's work and tens of millions of dollars in investment. It's a significant accomplishment to reach this milestone. In closing, I want to reiterate our commitment to supporting you all. We're building a network that your organizations can rely on and thrive on, and we've got Northern talent to help you get there. We all face big challenges as we adjust our business to meet the needs of the moment and the changing expectations of nature. I'm confident that by working in true Northern partnership, we'll contribute to a better tomorrow. Thank you.
Thank you, and thank you, Journey. My name is Tim Edgell. Thank you for the invitation to speak here today. My first time in Whitehorse. I see some friendly faces out there. I am from Ausenco. I'm proud to say that Ausenco is a member of Whitehorse's business community, and our office is about a 10-minute walk down the road. And I'm told just about everything's about a 10-minute walk down the road. So that's been great. I'm the Vice President of Technical Services at Ausenco. My job is to drive on technical quality and innovation within our environmental consulting business. Certainly that includes the North as well. But we're a Canadian business, and so we have representation from coast to coast and up into the Arctic as well. I'm I'm here today to talk about geomatics and the role of geomatics in resource development and some of the service offerings that we have, and we're not unique here. And really, the craft and the business of geomatics is about spatial information, collecting spatial information, the tools and technology used to collect that. We heard a little bit about that just a moment ago. The analysis and the applications to interpret and process vast amounts of information. And then on the very end, which is where my colleagues sort of work, is in the service delivery, and that's in the interpretation and delivery of the geomatics information using the tools and the resources that are available, sort of in the consulting space. The geomatics industry overall has been growing rapidly. We've seen incredible, even over the course of my career, which isn't dating back decades, there's been incredible progress on what geomatics means to the projects we work on. I know when I was starting, thinking of geomatics and GIS is about putting dots on a map. It's just in the course of like 5, 10, 15 years, it's come so much further than that. And I'm going to show you a little sample of some of the things we're working on now to demonstrate that. And it's going to continue to grow. The projection for geomatics professionals is that this industry will continue to grow rapidly across all the industries and sectors that we operate in Canada over the next 5 to 10 years, and that's really exciting. And so I guess then the question becomes why, and I think hopefully we'll be talking about a little bit of this in our panel discussion today, but why is technology growing so quickly, and why is geomatics in particular, why is there so much growing demand for it, and why will that continue? And I attribute it really to 3 things. First of all, we've probably never been at a time or place in the sort of a human experience where local communities and global communities are more knowledgeable and tuned in to the potential impacts of resource development, potential impacts of the things that we hold and cherish, including the environment, including whether it's the natural environment or the ecosystems or some of the resources in the environment that we use, whether it's how we see the environment and whether there's going to be something blocking my view from the beautiful landscapes that you can see around here. So I think this is a real contributor to the demand of something like geomatics, and I'll talk a little bit more about that in a minute. It's also that this understanding of resources and resource development is now global. And people want to see that their values and their knowledge and their ideas are incorporated into the responsible development of our resources. And when I say global, I mean because there's so much information at our fingertips, thanks to Northwest and others, that if there's a development in your backyard that is similar to a development on the other side of the world, well, if something goes wrong on the other side of the world, it won't take long before you know about it. And you're questioning about if those issues also apply to your own backyard. And so there's no more sort of regional silos of the world, because we are in this rapid information knowledge age, and everyone is so tuned into what the issues are. So that's the one thing, is that I think that we are now just more, in general, more knowledgeable what the real issues are to developing resources. Another thing is the tools, the technology, the ability to analyze vast amounts of data, that's now at all of our fingertips. And in the past, and in the craft of geomatics, you might have needed a whole team to sort of work through issues. Imagine, even 10 years ago, doing terrestrial ecosystem maps, looking through the scope over the aerial photographies, trying to interpret what you're looking at. This was very laborious. It took teams of people. It took a very long time. Technology has caught up to the point where we can process the information, and almost anyone can do it. We don't need teams of people working on stuff. We can have a couple individuals working on stuff, or you can ask your kids to figure it out for you. We can all develop apps. We can all apply those apps in real meaningful ways. So I think that's a second contributor, is that just the technology to collect the information and then process it in a meaningful way has never been in a place that it's been right now. And then lastly, I think the third driver relates to our collective attention spans. And ADHD is real. I'm already looking forward to lunch. It's not just a thing with kids. This is everybody now, if you want an answer to something, you pull your phone out and you expect to get an answer in seconds. Or you don't even pull your phone out, you just talk at your phone, or as you're driving along, you talk into the air in your car, and you ask a question and an answer is presented to you. How many times have you filled out a form, and then if you fill your home address and press submit, if it doesn't work immediately, you're on the phone to customer service with Northwest Tel, right? Or so on. We're now in this point where we want answers. If we have a question, we want those answers, and we want those answers immediately. Can you roll the tape, please? I'm just going to play a video of some snippets. I asked my geomatics team to put together some video that just sort of highlighting. I have like my imposter syndrome is raging right now. This is a technology conference. So what I'm showing here, this is something that my team works on every day. And I'm not going to suggest that flyovers are new or innovative. We've been seeing flyovers in our business for many years. But what I will tell you that is new is that these flyovers are they're not just cartoons, they're geospatial sort of rectified images that have been produced by a very small team. And we're producing these types of imagery and videos and flyovers in days. We're now at the point where if you want something like this done for a project, depending on the complexity of what you're putting into it, it's like, can you have that by Friday? Don't quote me on that, actually. I am a consultant. We will scope and schedule it appropriately for you. But this stuff, now, if you think about the context of the complexities of developing resources, and especially in environments like this, in vast environments like in the north, how complex it is in terms of the logistics and the development, the scale of the developments themselves, especially if you're talking about mining, it's really hard to grasp. And for a community that wants answers right away, a community that's really tuned into what the issues are, and a community that likely has ADHD, they want this stuff handed to them and they want the answers fast. The days of directing someone to a shelf full of binders and saying, oh, well, you want to know how your project overlaps with, say, the moose population, look in volume H, appendix G on page 120, and there's a map there. Like, these days are done. We can't go there. That is not an appropriate way to engage with the community if you want real meaningful feedback on project developments. I think geomatics can provide a lot of these solutions for us. And there are many applications for how geomatics can be applied, just the analysis of spatial data, but surely community engagement and communication and planning of projects has to rank amongst the top of them. And this is just a two-dimensional imagery that we're showing, but all of this stuff can then be translated into augmented reality. That's where if you're holding up a tablet, you can look in your tablet, you can see your mine site down on the ground. Virtual reality with headsets, so we have all that technology to do that, where you're holding your resource in your hand, turning it around, going into the mine shaft. That's all very much available to us, and it doesn't take a lot of time now to do it. Another thing that I thought was really cool about the efficiency at which our teams can do this thing, and just I think in just where the field is going in general, is that half of our geomatics team comes from the video game industry. And so we're now combining sort of like the know-how of creating captivating and compelling graphics in the video game space, now that we have a whole new generation coming up who are very well versed in that, with the traditional sort of practices of spatial analysis and geomatics, and we're combining those. I think this is just a snippet that we're now we're going beyond creating digital twins of buildings. There's a lot of application there in terms of a large complex development. But now we're able to capture sort of with different delivery methods, whether it's satellites or drones, imagery of landscapes and environments and heritage features. And we can digitize those. And so in this case, here's a digital representation of some trappers' huts, some old wooden huts. You can see half of them are slowly returning back into the earth from where they came. Eventually those will be gone, but now we have a digital representation that can be kept forever. and that can be used as an engagement tool, brought right into the sort of literally into the hands of, or no, figuratively into the hands of the people who may care for those sort of values. And there's actually some really other exciting work that we're doing right now with the Gwich'in Land Use Planning Board, looking at some of their heritage features and capturing them in a similar way. But out of respect, it's not my heritage. I'm not going to show that to you today. But there's all sorts of applications, and I think it's now with geomatics we're extending beyond just sort of the infrastructure and the digital twin of buildings into sort of the digital representation of infrastructure, of environment, and even of culture. Thank you.
Hi, everyone. No, not this one. Yeah, maybe another day. Well, while we're getting the slides, I'll introduce myself. My name is Rachel. I work with BQE Water. I've been working primarily in the Yukon for the past 2 years. My work brought me to Minto, most recently Hecla, and also Victoria Gold. I'm part of our operations support division of our company. So I'm on site helping commission and bring plants up to steady state operation. And then once we're actually operating from day to day, nailed it. Then I'm helping to look at the data, trying to identify how is the water quality changing in the feed, how can we do things better, and maybe are there any capital improvements that we can make to the plant to, again, make things better, because ultimately we want to have resilient operations where we can trust that we're going to be creating on-spec water all of the time. So as I mentioned, I've most recently been at Keno Hill, so if anybody's visited Keno Hill, you might recognize this shot. I took this up at Signpost, and if you haven't been, highly recommend. You can hike or you can just drive to the top. It's great. Right, I have control. So Hecla purchased the Keno Hill site in 2022, and BQE was brought on site this year as part of a operations support and improvement contract. The Keno Hill site is 2 active underground mines, and each has its own dedicated water treatment plant. This is a shot of one of the settling ponds at one of the plants. And even just looking into the background, like the environment here, it's pristine, it's beautiful, and we're doing everything we can to keep it that way. So I wanted to give an overview of what water treatment looks like at Hecla. So here's a picture of the exterior of one of the plants. There's 3 main areas of contaminants of concern. The first is metals. This is a lead and silver mine, so there are some of these metals found in the water. There's also solids because of those underground activities. And finally, there's ammonia because of the blasting residuals. We have ammonia and other nitrogen species like nitrates that come to the surface. So the underground water travels to the plant through a series of sumps, collecting some of those contaminants on the way. These metals are removed through chemical precipitation. We use coagulation and pH adjustments so we can drop those metals out of solution. And then those precipitated metals, as well as those fine solids, can be flocculated together and settled in a clarifier and also a settling pond. And if it's required, because ammonia treatment isn't always required at this site because it is relatively low levels, then we use a process called breakpoint chlorination. This is the same process that you're going to see at your local swimming pool. So an excess of bleach or hypochlorite is added to completely oxidize that ammonia. So now you're going to have a stream that's free of ammonia, but possibly some residual free chlorine. We quench that with another chemical, and then it's ready to be discharged to the environment. So here's a shot of the inside of the plant. So we have 3 main steps, but it actually is all happening within a really relatively small space. And this is the plant what it looks like today, but Hecla is in the process of doing some major capital improvements to this plant, and they're working with Water Tectonics. You can see their logo on the bottom, and they graciously allowed me to share a 3D model of what a portion of the plant is going to look like. And the reason for these upgrades is to add some redundancy and resiliency to the existing plant, and also to expand some of the treatment capacity. So there's 4 main upgrades that I want to highlight. So first of all, the feed from underground can vary from day to day, or from hour to hour, or from minute to minute, depending on how recently a blast went off underground, how often the sumps are being mucked out. So feed tanks are going to be added to this plant so that it can dampen out those surges, because ultimately the more consistent your feed is to the plant, the more consistent your water treatment plant is going to be operating, and therefore the more consistent your effluent quality is going to be. So that's one big improvement. Secondly, there currently is no filtration in this plant. There's now going to be 2 more additional layers of filtration added after the clarifier. This is going to add multiple layers of redundancy, and if there is any sort of process upset because of that spike of solids in the feed, there's multiple layers that are going to catch any residual solids, and it also improves the overall removal efficiency of solids. Thirdly, the ammonia treatment is going to be brought within the building. So right now it's in a separate connex. It's much easier when you're operating plants, especially in the Yukon during the winter, when everything is geographically close, centralized heating of this system, and less heat tracing of piping going between buildings. And the actual capacity of the ammonia removal is going to be higher. So that's future-proofing this plant so that if blasting, like as the mine develops, they're going to be blasting more underground. That's going to mean more ammonia. So now this plant is going to be able to handle that increased load. And finally, there's going to be additional layers of automation and online monitoring. This is really important when your plant isn't always having somebody at the plant 24/7. So there's going to be online analyzers that's going to be measuring ammonia, for example, in the effluent. And if the ammonia is above the permit or approaching the permit limit, then valves are going to automatically reroute that water back to the feed stream so that it can be retreated. So some other advancements that are happening at the Keno Hill site, and this can also be applied to other sites, is source management of your contaminants. So I mentioned that solids and ammonia are some of the key contaminants that are being managed. There's things that can be done underground to settle those solids, or have increased sump capacity so that those solids can be settled underground so that they're not coming up to the plant so that the operators have to manage them. One other important facet is diamond drilling, or diamond drills underground. They're actually looking for, they have to use a medley of chemicals so that they can get representative core samples. And this is so important to steer the direction of mining. It's going to be informing the geologists of where they need to actually extract the ore. But because it's an introduction of other chemicals happening underground, it's much easier to treat those if it requires treatment at the source before it gets mixed with all of the other underground water. So it's good to understand what are the impacts of other reagents on site and what impacts can that have at your water treatment plant. pH control is very important for metals precipitation. And you can easily have a plant upset if your feed quality changes and your pH controller can't react fast enough. So being able to tune your controller so that it can react to every single different type of feed that your plant is going to see is really important. So we've done some of that work in fine-tuning that pH control so that our pH remains very constant at our set point. There's also been work in installing additional online analyzers and providing more treatment, tools to verify the treatment on site. So that can be bench testing equipment. Sites usually have on-site assay labs so that you can daily verify that, yes, we are meeting our treatment targets. And finally, communication. There's so many different groups working on and operating mine towards the same goal. You have your underground workers, you have your site operators that are operating the water treatment plant, you have the environmental department, mill. We haven't talked about mill reagents, and I won't touch on that today, but that can also impact your water treatment. And finally, you have engineering groups coming on site. And transparency is the best tool, and that sharing of knowledge, because everybody has unique knowledge sets on site. So by sharing that and identifying like, oh, something might be changing in the process, is that going to impact your work? Because then you can react and possibly plan so that you're not going to be jeopardizing your water treatment at site. So in general, the proactive approach is the best approach. Hecla's been doing a great job of this by assessing the plant now before it even needs to go through an upgrade for increased capacity. It's like we're building in resiliency now, and it's often quite a bit cheaper to try and forecast your future needs than react to a problem when it's much more difficult to manage. Water can take up a lot of space, and if you start storing water because you don't have the ability to treat it today, then that could cause some significant capital headaches in the near future. So definitely try and forecast and predict rather than react. Number 2 is understand where your contaminants are coming from. Are these contaminant levels going to be changing in the future? Because that's going to help feed into planning for your water treatment needs. And overall, we want to build resiliency into our treatment plants, having those secondary treatments like other layers of filtration, having those automatic bypass valves, having online sensors that are not only measuring pH and turbidity, but also ammonia and free chlorine. There's lots of different technology out there. And I wanted to end with just some of the challenges that come with working in water treatment in the Yukon. Lots of these are not going to be surprising to anybody, but lots of these places, they're remote locations. It creates logistical challenges. It's also a relatively short construction season. There's increased costs because of that short construction season and the logistical challenges of getting, you forgot to order a probe and now that's going to take 5 weeks to arrive at site. With specifically towards water treatment, there is no qualified assay lab located in the Yukon, so that's an additional amount of time that you have to wait before you can get results back. In some cases, there's prescriptive permitting requirements, which limits which technology can be applied. We see this in reclamation sites. And finally, no one site is the same. There's no one approach that's going to work for all sites. So every site's going to have its unique challenges, unique water chemistry, and just because something worked at another site doesn't mean it's going to work for your site. So unfortunately, each site, you need to do the hard work and understand everything you can about it before you try and suggest a solution. Thank you.
Hi everyone, I'm Jack Milton and I'm the VP Geology with Fireweed Metals. And yeah, today I'm going to run through a presentation of muon tomography and you know, what is that? But there we go. So we're going to go through a journey here through time and space. And we're going to be starting tens to hundreds of millions of years ago. at the death of a star. And, you know, when stars reach the end of their lifetime, they undergo these reactions, these runaway nuclear reactions, and they explode into supernova. And when that happens, these supernovas give off a lot of gamma rays or cosmic rays, and these then start traveling out through space around these explosions. These things are not that common. You know, in our galaxy, the Milky Way, there's many, many stars, but you're likely to only ever see one supernova in your lifetime in the Milky Way. But they occur, you know, in other galaxies many, many parsecs away, and that radiation is constantly reaching the Earth. So these cosmic rays, which may have been generated 100 million years ago when the dinosaurs were walking on Earth and leaving footprints up near Tuladlini Ross River that you can go and see today, it's taken all that time for that radiation to reach the Earth. And when it does, it interacts with the atmosphere, the upper atmosphere of the Earth. And this results in particle collisions. So one of the products of these collisions is the generation of a subatomic particle called a muon. And so what is a muon? Well, muon is like an electron, but it's heavier. It's about 200 times heavier than an electron. And they're raining down from space or the upper atmosphere at a very well-known constant flux of muons. And these things travel extremely quickly. They don't last very long, and they travel in straight lines, and they can pass through solid objects. They go through, they arrive at the surface of the Earth at a rate of about 1 per centimeter squared per minute. So they're all arriving, traveling through us right now, through the Earth, and they'll travel for several kilometers through the Earth before they end their journey. And we're using these muons in exploration by detecting them in detectors. And so how do we do that? Well, there we go. Here's a visual representation of what's going on here, of these particle collisions resulting in this flux of muons that travel down to the Earth. So if you're a mineral deposit, some mineral deposits are quite dense. Not all of them, but some of them have a much higher density of rock than the surrounding rock. And muons are slowed down or deflected by more dense rocks. So this works using the principle that muons are detected at a detector, and we deploy them down drill holes. And we survey everything. We've done LiDAR on the surface. We have a very good 3D model of what topography looks like, and we know exactly where these detectors are underground. And we can calculate what the flux of muons should be at that detector. We know what it is at the Earth's surface. We know what it is at the bottom of the sea. And in many places on Earth, this has been a field in theoretical physics for many years, or in particle physics, I should say. And this is really the first time that this has been applied to exploration by IDEON, which is a company that is working on this technology and is leading the field in muon tomography. And we're partnered with IDEON working on this project. So if you're this muon arriving down here from the upper atmosphere, you hit the surface of the Earth and you keep traveling. Here, 300 meters down, maybe a kilometer or more. And when you hit some dense rock, maybe this is massive sulfide, much denser than the host rock around it, not all of those muons reach the detector because the detector's down here. some of them are going to get deflected or slowed down or stopped by this denser rock. And so this results in shadows. And you can see those shadows represented on this radiograph by these darker areas. And from that, we can then triangulate by using multiple detectors in different locations, and we look for the shadows. And there's some very complex mathematics that goes on calculating and basically producing a block model of subsurface density based on the arrival of muons. So these detectors sit down the hole, and they are deployed for many months, and they measure the arrival of every muon and the direction that that muon is arriving from. And so this is kind of a representation here. Maybe it's around a mine, maybe you're using this in exploration. And down your drill holes, you have detectors deployed in orange. So with many of these detectors deployed around a target, you can then triangulate in 3D and work out what these dense bodies might look like in the subsurface. So why is this useful? For two reasons in my mind. One is that it accesses a search space for exploration that's not accessible to any other technique. For the types of deposits that are dense, you typically might see anomalies from traditional methods like ground gravity in the top 100, 200, maybe several hundred meters if it's a really big ore body. And below this depth, you're kind of blind to most deposits. But if you can get detectors down below those depths and you look back upwards detecting muons, then you access this search space down here that's not accessible. So I think that one of the real strong use cases for this is in exploration, in looking at a new search space with a new technology. And the second reason why this is useful is because you can get away with less drilling. So if you did your first pass of exploration, say with 4 drill holes like this was not a mine environment, if this was a greenfields environment, and you deployed these detectors down somewhere where you had some idea about mineralization, maybe you hit on one drill hole, and you go on the next step here, and you deploy these things, you can then figure out exactly what it looks like in 3D at that stage, and maybe you save yourself a dozen drill holes or more in order to try and then delineate that deposit and drill it out. So it lets us drill a lot less, which has an important efficiency impact for both for cost, but also on reducing impact in the environment. Every drill hole that you save drilling reduces surface disturbance at the collar. It reduces perhaps permitting thresholds of how many pads you want to build. It reduces our carbon footprint of flying a helicopter back and forth to a drill hole that ended up unsuccessful, that we could avoid drilling completely by targeting precisely with muon tomography. So these are the sort of cones of vision of these detectors as they look up and around the drill holes. So you have to kind of get under these targets or to the side of them to be useful in detecting them. So what's our journey been on this so far? Well, we've been working with IDEON and the precursor company to IDEON for many years to try and make this happen. We've been talking to them since about 2018. They first developed this technology as very large detectors that are a quarter of the size of this room, and they could be dragged in underground mines and deployed in underground mines. And then their next version was like the size of a fridge, and it was a bit better, but you still can't put a fridge down a drill hole. So it was not until around about this time, 2020 or so, that they developed the world's first downhole muon sensors, muon detectors. And so we were the first junior company to try and get these things deployed back in 2021. This was us trying to deploy at MacPass, and as with any new technology, it was a bumpy road, and we had a lot of issues with the drilling and technical problems with the drilling that meant that we couldn't deploy in 2021. We tried again in 2022, unsuccessfully. But we persevered, and this year we were managed to successfully deploy down 3 different holes at our new discovery at Boundary Zone. And even better, we've been part of these digital supercluster projects, which are these collaborations between academia, industry, and governments and startups to encourage new technology. So we actually got the whole survey paid for by the Canadian government, and we didn't spend a penny on this ourselves. And this is what it looks like. So this is Boundary Zone. This is the massive sulfide zone here. And we've deployed in 3 different holes. We've got 7 detectors sitting right now at MacPass detecting muons as we speak. And we deployed between about 400 and 600 meters depth, imaging a volume of over 1 billion cubic meters of rock. We set up these power systems out there. It's going with a generator and a battery and a Starlink system, and we can monitor these things live. So it pushes data back every 8 hours to Vancouver, and we can see the status of those detectors, which will passively measure muons from now, we deployed in September, right through to before next field season in May. So we'll have these data, we can use this off-season to our benefit and get a high-resolution 3D model of subsurface density in order to drill some of these targets next year. And so this is sort of a little taster of how this works. We're really looking forward to seeing what data comes out of this and what targets we can generate next year. It's too early days to tell yet on what the data are seeing. We've seen some preliminary data. The detectors are working. They're detecting muons. Yeah, we are very, very excited about this new technology and being one of the first to use this in exploration. So I'm going to finish there and leave you with a story of the muon, which was discovered almost 100 years ago. But when it was first discovered, it wasn't known as a muon. It was a subatomic particle, like a neutron or an electron or a proton. They all end in ON. And it was predicted by a Japanese scientist by the name of Yukawa. So the first muons were actually known as Yukons. So we've come full circle here. But it turned out that the particle that Yukawa predicted was actually a little bit heavier than what the muon turned out to be. And that particle is now known as a pi meson or a pion. And muons became known as muons. So thanks for listening, everyone, and thanks for having me on this panel discussion.
Thanks, Jack, and everyone else. So what we had hoped to do is then just have a little bit of panel discussion where I have some prepared questions, but if we have people in the crowd who are interested, we'd love to take your questions too and talk about technology. We have 4 experts. Can I get in one question? And then I'm happy to let you take in one. So what I thought we'd just start with is one that I think really spreads across the panel in terms of what technology do you see as being close to widespread being implemented within 10 years? You've talked about what you're doing right now, but what do you see in the next 10 years?
I can start with that one, and I touched on it a little bit during my talk. Oh, more technology.
You don't have to touch.
Hello? Okay. We're going to get through this. It's, I think from my perspective, I think in a lot of the technology that we have is not necessarily new. And that's how I ended my talk, showing some applications of the technology in geomatics. which I'm sure many of you have thought like, well, I've seen that before. I think the novelty in what we're going to see in the next 10 years here is the accessibility of these tools, and going from a really resource-heavy, big team, production team to sort of get these endpoints, to having that same technology literally at your fingertips, to making it more accessible to the point where you don't need to be an expert to apply this stuff to your project. I think that's the revolution we're going to see in the next 10 years, is more around accessibility. And then as soon as accessibility is there, then it'll be application to then the new applications will start coming. And the limit to that is just human creativity, I think.
Thanks, Tim. I agree. I think what we're seeing a lot of times is the sort of nascent applications of the technology changes and developments, advancements that we've seen. So, some of the things like, remote workforces, we can't train, our tech in Burwash Landing or, Arctic Bay to necessarily know, the nth degree of all the technology that's been deployed there, but we have the technology to be able to get them the information they need at the moment they need it to save us on travel. We've been deploying a lot of green technologies. Some of you have seen our headquarters building, which is a bit of a showcase. A lot of our buildings aren't, and trying to upgrade, take down microwave towers, reduce our reliance on diesel generation. Things like electric vehicle batteries are allowing us to cycle power and reduce some of our diesel footprint. So as more and more of these technologies become standard, more efficient, more cost efficient to deploy, we're able to take advantage of that, which, especially given the remote areas that we're working in, becomes really important for us.
I completely agree that we might not be implementing things that are necessarily new, but I think in the next 10 years, we're going to be seeing some, like all these great research projects that John Steer was telling us about this morning. It's like, I think we're, as a mining industry, there's less risk aversion to trying new things. Like before, I can mainly speak to water treatment. You used to look down the road at what the other site did and then just try and reproduce that. But that doesn't cut it anymore for a number of reasons, like environmental regulations have changed, things are becoming more stringent. And along that train of thought, a water technology that I think we're going to see become more prevalent, and it seems to be accelerating, is the application of membrane technologies and ion exchange resins, because you can get down to such ultra low levels. But with that, it introduces new challenges, which with membrane technologies, now you're concentrating your waste. Now you have a waste stream to deal with. That can be beneficial if you now can deploy technology on a much smaller volume of water, or it could be a new headache, and now it's going to be sent back to your tailings pond or some sort of pit to be able to deal with later. But there's a time and place for membranes, and I'm seeing more and more projects getting it applied. So it's a great technology, but yeah, there's challenges. And same with ion exchange resin. You're getting down to those ultra low limits, but now you need to regenerate your resin. Now you have a waste stream. So we want to just make sure we're designing circular treatment processes so that we can, yes, regenerate our systems, but then also treat that waste.
Thanks. Yeah, I think what I can speak to is kind of the other end of the life cycle of a mine in exploration, and I think there is an industry. There's a real need to be more efficient, and technologies that can enable that is going to be the solution to the amount of capital that needs to get deployed in order to find the deposits that are going to fuel this energy transition into a lower carbon economy. And I think ways that we can do that, involve AI, using that a lot more. I think communications, in being connected, and especially in remote areas like this, increasing the efficiency of those exploration operations. And I think it's something that, you know, we're going to have to do as a sector. I'm sure we've all heard the narrative of declining head grades and discovery rates dropping, and it becoming harder and harder, or seemingly, to raise capital for exploration, and fewer companies are doing that greenfields exploration. So in order to succeed, we need to become more efficient as an industry, and I think harnessing these new technologies is one way that we can help to do that.
Thank you. If you had a question, happy to.
Yeah, sorry, this is quite specific to Jack.
Go on.
And you know, there's many of us excited about the Yukon U1 technology. You know, it was a great talk, but you know, for the data geeks, slightly disappointed. I mean, I know it's only been a couple months, but are there any shadows? Can you give us something?
Yeah, thanks, Dave. Yeah, so the survey was planned over a period of 8 months, and this is one of the ways, efficiency, that IDEON have implemented in their workflows, and that within 8 days of starting the survey, they were able to meet with us and say, this is the first data that are being produced from this. And you know, even 6 months ago, that would have been a many-week process for them to start processing the data, but in the complex back-end stuff that I don't know how it works, they turn it around in 8 days. And when you look at those data, you produce two things. One is a null model, where you assume all density is regular density. And then you look at the observed data, and they should be kind of similar. Where you have differences between those two data sets is where you have anomalies of either denser rock or less dense rock. And you can produce these z-scores by subtracting one data set from the other. And that's how one way that we'll look for some of these anomalies. And yes, the data look good. It looks similar enough to the null model that we know that it's doing the right thing and it's measuring them in the right way, and the muons are arriving pretty much how we think they should be. But it's early days to tell, so all we have is a very fuzzy looking, sort of pixelated image, but that will improve over time.
We'll look forward to next year, hopefully seeing a presentation with actual results. Is there anyone else in the crowd who had a question, or I'll continue down my list? Okay. How about talking about, we live in the north, and what technology advancements do you feel are driving northern innovation as opposed to innovation anywhere else?
I can start. It's not really a technology advancement, but I think it's an advancement in mining companies' responsibility and them really taking that torch and trying to do the best job that they can. So it's like, we want to protect the environment, we want to have positive social impacts, we want to basically be a good steward. And I think that's a great driving force to be able to try new things, implement better technology. Like, there's these research programs that are happening with the government like that. This is all great news stories. So that's not really a technology advancement, but I really think mining companies' perception is so important, because you do need buy-in from the entire community and investors. So you can't just keep on reproducing the status quo. We do need to advance and try new things and implement the latest and greatest.
I know for myself, John Steele talked about my tax program, and I really see that as one that up here is, I know you guys looked at funding from that source too, it's a source that's so important up here in that we're smaller, right? So being able to double your funding by working with the federal government funding to double the industry funding that then you can pair with the university funding, that you can actually move things forward. So that's one that I really feel is important in the North. How about a question on AI, because I know I get asked this all the time, is how does your company use AI and how are you trying to use AI in the future? Jack, do you want to start with that?
Yeah, absolutely. So, we use AI all the time, probably without even knowing that it's AI that we're actually using. And in its simplest form, it is just advanced data analytics is all AI is really. And the simplest form is a linear regression model. Y on X regression, that is AI. You're moving from just looking at the data to moving to being predictive in how you're thinking about this. And the models get more and more complex as you look at other parts of the AI sort of ecosphere. And we use it in many ways directly in exploration. We use it to define geometallurgical domains. We use it primarily with geochemical data. Hyperspectral data, we have geologic AI scanning our core. We look at hyperspectral, XRF, LiDAR, visible RGB light, and all that stuff gets crunched into an AI model and to try and predict what minerals we have in the rock. And I think that this is really important from an efficiency point of view of trying to extract the most value out of a deposit, but also the most metal, and trying to become predictive in terms of metallurgy and recovery. And as much as it's a sort of economic tragedy of letting metal go onto your tailings pile, it's also an environmental tragedy because you're not getting the most that you could from that deposit. And a good example from that is tungsten. The Cantong mine, when that was operating, when it first opened, it was a very complex flow sheet, and they were getting 0.5% WO3 tungsten in their tailings, which is higher grade than most tungsten deposits. And so it's one of these things where we can implement this to be more efficient with what we have and to ingest the huge amounts of data that are commonly not even touched in exploration. They'll sit in a database or in a printed out a scanned PDF copy of an assessment report, or one of these formats that we're all used to dealing with. But it's just one example of how we use that to try and be more efficient with the data that we have.
I think AI, and first of all, ChatGPT wrote my speech today, so let's start with that. I think in geomatics more broadly, though, it's really being implemented, and I think, like Jack said, I think you're using AI even at times when you don't know you're using it, because it's on the other side of the interface of the user interface. And so if you think of, just back up like 5-10 years for anyone who's done, I'm an ecologist by training. If you've done terrestrial ecosystem mapping, you used to fly over a terrain with a camera, with film, taking photos, and then you'd have to come back and you'd look through your stereoscope and you'd classify what you think you're looking at. You'd have to do some ground truthing. Mosaics, orthomosaic, orthorectified mosaics. Again, you have a series of potentially tens or dozens, hundreds of photos, and you have to stitch those together with reference points to make sure. This is the labor-intensive work that AI is gobbling up. And in a world we live in now in geomatics, the study of space, and that includes, like I said, the delivery systems, so satellites taking thousands, millions of photos, digital photos. We all do it now. You just hold your finger on the button. You can take hundreds of photos and you decide which one you want later. In geomatics, AI is now working in the background to stitch those together, and it's taking away the resource and the resource demands needed to do that work. And it's not just in terms of processing, it makes it a lot more efficient. It makes it a lot more user-friendly. It opens up that, it makes it accessible to people who don't need the highly specific training to do that type of work. And it makes it more cost effective in the end. Some of these videos that I was showing you started with like a drone overflight of a video. And then from there, sort of information, like through CAD or whatever, other spatial information being layered in, like in a GIS platform. But to make that and turn that into a video with animations, you know, computing power, machine learning, and recognition of the images, like AI is going to be driving a lot of this. And it's not only going to improve the user interface, it's going to make the stuff process much faster, and it's going to be much more accessible to sort of a number of applications just because it's cost effective.
Thank you. The one that I know comes to mind for me is when I was working at Minto in the mill. The recovery rates, everyone cares every day. You hear about the recovery rate in the morning meeting, you hear about it at your end meeting. The ability to process that data so much faster meant that instead of one guy doing some calculations on an Excel sheet, all of a sudden you were getting this in real-time data, and it allowed you to make changes, right? Like that when we saw mercury come into the mill, you could right away be like, oh, quick, we have to fix our reagent use. Whereas it used to be some guy was looking at the data at the end of the day, worked a couple hours overnight, and then got an answer for you, right? So it's completely changed some areas. Do we have any questions from the field, or I'm going to keep going? All right. What technology has changed in your area the most in the last 10 years? Like what has moved forward and changed how you're doing your business today?
I think online analyzers, they can be really expensive, but like for example, at Hecla Keno Hill, they have an online ammonia, monochloramine analyzer. It is, I think, $50,000 to install one of these things, but it saves so much time, and also having to send multiple sites off-site to get that data. And now your operators can have that real-time data to make reagent changes, or have that data actually controlling your reagent doses for you. And so that specific part of online analyzers is great. They also have them for silica and phosphate. But then there's other analyzers like for specific metals, which we're just not quite there yet. So I'm hoping somebody can figure it out. It's like we figured out, you know, these crazy subatomic particles. Like, can we figure out how to analyze selenium in line? That would be great. But yeah, the technology for online analyzing, and then also using that data in your process or communicating back to your head office or your office on site, and the interconnectivity of everything is just getting better and better, and I think it's going to keep on getting better.
I know for myself, it's a question that I get asked all the time on, like, why do we not have in a stream monitoring that we get results like this, that we can know, is it safe, is it not safe? And, you know, it is a challenge to understand, like, why we can't get metals done at the rate that we need. But I think it's an area where I know universities are exploring is inline testing, like being able to, instead of take your sample, send it to BV or ALS and get your result back in 3 days. Yeah. It's like, it's going to be right there, right at your fingertips. So it's one that I really look forward to. Anyone else want to go ahead, Jack?
Yeah, sure. I think sort of one thing you mentioned there was connectivity, and for us, that's been something that's really changed how we do things. And, you know, especially since Starlink came on, and sorry, Northwestel, I know there's other lower Earth orbit satellite solutions. But for us, we've used Starlink, and it has completely changed the way that we've been able to operate in the field. And we've implemented core scanning. The core will come in, we'll clean it, we'll scan it immediately before it's even logged in the core shack. And that day, the data are sent up in the cloud, and somehow I'm able to sit at home or in the office and see in very high resolution the core as if you're holding a hand lens right up to it the next day. And along with that, we get XRF, we get hyperspectral data almost in real time. And that has been absolutely game-changing in terms of how we can operate and adapt the program based on what we're seeing as we go. And the efficiencies that it's brought are huge in terms of the costs that we're saving, but also how effective we can be in exploration.
Yeah, it's definitely one. My brother works in oil and gas rigs, and he would definitely say, like, your ability to change the direction of your drilling, for example, in real time with someone in the office hundreds of miles away is game-changing for your costs, getting those under control. I have one. Oh, go ahead, John.
So this morning we heard about the process of monitoring and permitting, the need for better transparency during project construction. Do you think that sort of issue can be solved with these sorts of technologies that you're talking about, better transparency with regulators and the community?
Maybe you want to start?
I'll just quickly say I absolutely believe that's true, and I think that's, you know, why I'm an advocate of the geomatics applications in general. And, you know, it's not just the communities that want to know and want this information that's accessible. I mean, I'm an educated person, but I can quickly get into a conversation with a mining engineer and have no idea what's going on. So I think that's another, you know, just that engagement piece and the planning piece. It's not necessarily just to sort of seeking community buy-in or understanding of a project, but even just within the teams themselves to understand the massive amounts of knowledge and information that are factoring into a very complex situation. Absolutely, the interface is everything, and sort of helping people get there and get on sort of a level playing field of understanding to make an informed decision. So yes, I think, and I think that you've just put your finger on what will be driving the growth in disciplines like geomatics for years to come, is that broader need and desire for understanding. I mean, I think there's just more desire to know and have knowledge now than, you know, than what we've dealt with, and on a global scale.
Thanks. I think the thing that you sort of touched on implicitly is also the need for communication. When we did our fiber rollout throughout the Yukon, there was a lot of permitting involved, and you know, geomatics and being able to explain to community stakeholders what they could be expecting, both in terms of, you know, disruption as well as, you know, upside when the completion was done, was really important. But it's really understanding what it is that your constituents need, and that's what brought us to Shared Pathways, which, you know, in turn has led to the 60 North Unity proposed purchase. And I think it's really just finding out who those stakeholders are and finding a way to communicate your vision and ensure that there is shared benefit. And I think, you know, all these tools are critically important, and I think they will all help. You know, as we hear about muon technology, that makes it a lot more appealing for folks to say, sure, you can, you know, do that instead of, you know, drilling big holes. That sounds better for me. But it also allows people to make some informed decisions or look at some of the alternatives in ways that, no matter how great a communicator we think we can be, we have trouble getting across. So I think it's the combination of the visualization as well as some of the technology that we can all deploy to make a, you know, smaller environmental footprint and help align with some of the land stewards ideation that is sometimes frustrating for permitting.
I think the part of the answer that I'd give is, as an example, is at Minto when we were trying to look at the design of a tailings dam. What we had SRK develop was a 3D model that you could move around. And when we were doing a failure modes effects assessment with the regulators in the room and the First Nation, it allowed people to actually look at what you were talking about. Okay, is this gonna overtop? Well, you could move the model around and be able to be like, no, it can't overtop here, but it could over here. And it gave a level of certainty to people that just wasn't there before we had a 3D model that someone could actually physically look at. Okay, here's where the rock is, here's how high 10 meters really is, you know, what does a wave of 10 meters really look like? Well, I mean, I can kind of visualize that, but it's hard, right? Versus having something where you're actually looking at it and being like, okay, I can see how that's not a possible failure. And so I think for things like risk assessment, it's going to be a critical tool for educating the public and regulators on risk, is to be able to use these techniques. I think we're out of time now, but thank you very much to our panel. I really appreciate everyone volunteering to come when I went around and asked, and there were more people who wanted to talk than we had slots for, in fact, and that's a testimony to how much innovation there is in our sector, and we look forward to hearing what the future really does hold for things like Nuon technology. Thank you very much.